Hey everyone! Let me introduce myself really quick. I will be your eyes on this LEFOS laboratory tour here in Hamburg. The Innovation Center you just entered was built in 2018. And since we already started talking history, and well, I know history is not directly a synonym for interesting, but in our case, it really is the core and the heart of our company. We are proud of what we have achieved, and since our foundation more than 125 years ago, we paid great attention in maintaining a high level of expertise in our business and to marketing products tailored to the individual customer. I'd love to show you around, but first there are some steps to climb. Up we go. Let's see what we got here. The Coatings Laboratory. In here, it is all about application testing.
Hello, my name is Christian Fichner. I'm doing product development in the Coatings Lab, and I can show you something here. So this is a vacuum dissolver. We can prepare any type of coating, temperature and time controlled process. Here on the right side we have the possibility to apply any type of coating system. So we have different applicators to apply a film, or we can do roller application. And we have different possibilities to test the coating. So we have, for example, a pendulum hardness tester. We can measure the gloss of a coating system, or we can measure the adhesion with the crosscut testing equipment like this. With a speed mixer we can prepare any type of sealant or adhesive system, and we can do very fast raw material screenings. So my colleague is preparing a sealant, putting it to that type of cartridge. We can apply the sealant, for example, like this. And we are able to apply a film on the Teflon plate. So once dried, we can prepare these type of dumbbells. So we put it out here and can do the modulus testing with that type of dumbbell.
Tensile testing. I know where they do that.
Thank you. Hello, my name is Dr. Lars Wahlen and I'm head of the Quality Assurance Lab here at Lehmann & Voss. We are here in the mechanical lab and we will perform a tensile test on the specimen. Matthias will do the test. We have here several machines. We have the tensile test, we have the 3-point bending test in the middle part, and at the window there's our robot who can do several impact tests. So the tensile test is running already here. Thanks for visiting us here and see you again later.
Wow, that was great. Now let's head back to the Coatings Lab for some rheology insights.
Hello, my name is Eva Maria Kutschmann and I'm part of the product development team. We use rheometers. We have in total 5 instruments. This is one of our rheometers. We use these instruments to characterize the viscoelastic and rheological properties of formulations. We can test samples from very low viscous liquids to soft solids, viscoelastic materials. I've prepared a test for you, so we can start the test immediately. And then we start the measurement. Yeah, this should give you a short impression on what we do in our rheology laboratories.
You see, this facility has state-of-the-art equipment, and even more important, state-of-the-art people. But now it's definitely time for some rest. Oh, quite a comfy chair. Nice. Let's see what we got here.
Hey there, it's Adriano from LEFOS laboratory in Italy. I hope you are enjoying the tour so far. I'd like to share with you the activities we organize in our laboratory here in Italy. We test new raw materials to evaluate their quality and to compare them with market benchmarks. In this way, we support our customer in the material replacement process in development of a new formulation. We produce finished formulation to show our raw material efficacy and benefit. We perform stability tests and some application tests. Thanks a lot for your visit.
Greetings back to Italy, and thank you. Now, let's head to the 3D printing area.
Hello, my name is Markus Rechberger. I'm member of the 3D printing team and welcome in our 3D printing lab. We have here different printing technology available. What you can see here is the filament printing area, and those machines simply work by extruding a very thin filament to a solid layer of plastic again and again repeatedly, and at the end you have such a complex part in hands, quick and easy with no tooling cost like you have in injection molding. And it may look like we are in printers, but we are in materials. We are developing materials for those printers to bring it to an industrial level, and yeah, this is how it looks like at the end.
Cool. I like that.
You may think that 3D printing is only about producing small parts, but it's not. As you can see here, this boat is fully printed, so it's possible to scale it up, okay? Here's another technology that we are providing. It's called laser sintering, and you see the size, it's already industrial. We are developing the material for this specific technology, and you can see here how it works. So a very thin layer is selectively molten by a laser, and at the end you have a complex part in a powder bed. That's an important difference to other technologies because it gives you 100% design freedom. At the end, you can have something like that, so very complex parts that you cannot produce with any other technology. I hope you liked my tour, and see you soon.
That was impressive. Let's see what else we got here.
Oh, hi! My name is Ann-Christine Schulten. I'm part of the Master Batch product development team, and this is our blown film line. We use it to produce films with our master batches or interesting additives for further testing, because it's a 3-layer blown film line where each layer can be fed separately. Just putting the additives and master batches in the hopper, we have so many possibilities. For example, we can see what the bubble structure made by our blowing agents looks like, or just modify the surface by putting the additive only in the outer layer. The film later can be tested in-house or at the customer for the special functionality, for example, surface quality or flame retardancy. So I hope you enjoyed seeing this machine in action, and have a good day. See you soon.
Good news. We're going back up again. Love these steps. And here we are. Hi again, Mr. Wallen.
Welcome to our Carbon Black lab. Better don't touch anything here to avoid getting dirty. In this lab, we can test nearly all important properties of carbon black grades, from sieve residue, fines, and pellet hardness to the iodine number, pH value, and oil absorption number. Marco Sturm will show you the calibration of the equipment for the oil absorption number, and therefore he will apply a carbon black sample to the kneading chamber, where then small portions of oil are added and the torque of the mixing equipment is determined. And the oil absorption number is then the highest torque in this experiment. The next stop will then be our particle size distribution measurement.
Last room of the tour coming up.
Hello, we are here now in our powder characterization lab. One of the most important methods for us is the determination of the particle size distribution curve that we do with laser diffraction here with this equipment. And we can switch between dry dispersion that you can see here and over there also wet dispersion. My colleague Abdou Omer is at the moment performing a test to determine the wet density and the permeability of diatomaceous earth that are used for the filtration of beverages. So we can see the end of the test in a minute, where a filter cake is collected here and will finally be measured how high it is compared to the volume that has been used. And that is the end of our tour to the lab of Lehmann & Voss. I hope you enjoyed it.
All right, it's time for me to say goodbye. It was a pleasure being your eyes, and I hope you enjoyed this visit at our laboratory in Hamburg.